All right, so today we're going to be starting section 6, which is on solving quadratic equations by factoring. So what we've been doing this chapter so far is we've just been factoring. Today we're taking it one step further, and we're going to be able to set these quadratics into an equation, and then we're going to be able to find out what x actually represents that would satisfy this equation. In case you're wondering why I'm not here today, my kid is sick, so I won't be here today and tomorrow. So today you'll get to enjoy a video. So just follow along, and it shouldn't be too difficult of a day. So first off, what is a quadratic equation? Well, it looks like those trinomials or something similar to those trinomials that we've been factoring and in an equation. So typically, standard form is going to have your squared term first, your x term second, your normal number third, and then the equation is going to be set equal to 0. And that's what's going to allow you to solve a quadratic equation. Whenever we solve quadratic equations, we use a property that's called the zero factor property, which states that if you multiply two numbers together and it equals 0, then either one or the other of those numbers must be 0, or of course both of them can be 0. So that allows us to take each of the things that are being multiplied and individually set them equal to 0 and solve each of those very simple equations for the variable that's missing. So the solutions of these equations are most of the time called solutions, but sometimes they are called roots or zeros or intercepts. So if you see any of those four types of words asking you for one of those four things, they all mean the same thing. They're telling you to solve the equation and find the solutions. So these first four examples on the front page are already factored for you. So this is, what we do when we factor. We got these two things being multiplied together. So what we're doing is we're going to, once it's in this form, it's really easy. There's just two small little steps. What you do is you take each factor according to the zero factor property, and you're able to set each factor individually equal to 0. So that means I would take x minus 3 and set it equal to 0, the first factor. And then the second factor, x plus 1, I'm able to set it equal to 0 also. And then you look at those equations and you're like, man, those are super easy to solve. You've been solving these equations since you were in 6th grade. All you have to do on this one is add 3 to both sides of the equation, and looks like x equals 3. And then the other solution, you would subtract 1 from both sides of the equation, and x equals negative 1. So you're going to get usually at least two solutions to these. So 3 and negative 1 both work. So number 2, you'll see really it's the same thing. Take each equation, or each factor, set it equal to 0 in its own separate equation. And then those are nice and easy to solve. On the first one, you subtract 4 from both sides, and x equals negative 4. On the second one, you would add 5 to both sides, and x equals 5. There's your two solutions. Okay, sometimes you'll factor things and they'll look like this, where there's an x on the outside of the parenthesis, and then your normal looking factor equal to 0. It's really no different. You take each factor and individually set them equal to 0. Our first factor is just x, so it says x equals 0. That one's already solved. The second one, 5x minus 2 equals 0. That's not too difficult to solve. Again, you've been solving these since 6th grade. The first thing you would do is add 2 to both sides of the equation. Those 2's on the left cancel. 5x equals 0 plus 2 is still 2. And then you know what to do from here. 5x equals 2. You divide both sides of the equation by 5, and 5 doesn't go into 2 evenly, so you just say x equals 2/5. So you've got both of those solutions. X equals 0, I'll just rewrite that one next to here, x equals 0, and x equals 2/5. Both of those would work. And last one, you'll see same thing as number 3, just to reiterate, we'll do another one like it. The first factor is just x equals 0, that's one is already solved. The second one, 7x plus 6 equals 0. That one takes 2 steps. First thing, you would subtract 6 from both sides of the equation. And 7x equals negative 6. And second thing, to get rid of that 7 in front of the x, divide both sides by 7. And again, 7 doesn't go into negative 6 evenly, so x equals negative 6/7. And then don't forget about that one. Also, it equals 0. You can just put a comma if you'd like as well. So negative 6/7 and 0 are your two solutions for x. So that is what we're going to be doing today. So on the back, you'll see we have those normal looking trinomials, and we're going to factor them like we have been for the last 5 sections, and then set each factor equal to 0 and solve. So that's what this step says, or these steps up here say. It says first step is make your equation set equal to 0. Second, you're going to factor completely. Then you're going to take each factor and individually set equal to 0, solve those equations, and then of course you can check your solutions. Remember, when factoring, always look for a GCF for your first step. Okay, so let's look at number 5 together here. X squared minus 9x minus 22 equals 0. So it's already set equal to 0. It has to be set equal to 0. So then we're going to go ahead and work about factoring this quadratic. So this is like one from, I think, section 3. There's no term on the squared term, so we just look at that third sign. Since it's negative, we're going to go ahead and go straight into our parentheses. We're going to have one x plus some number and one x minus some number. We just got to figure out what those numbers are. So remember, we look at this 22. The ways that we can multiply to 22 are 1 times 22 and 2 times 11. There's no other way to multiply to get to 22. We're looking at the factors of 22 that subtract to make negative 9. And we all know that 2 minus 11 is negative 9. That would be a positive 2 minus 11. That makes negative 9. Remember, the other way would make a positive 9, so we need to make it like this. So it's now completely factored. Now that it's factored, we set each factor individually equal to 0. So if x plus 2 equals 0, we would subtract 2 from both sides of the equation, and x would equal negative 2. And on this one, we would add 11 to both sides of the equation, and x would equal 11. So there are your two solutions. 6 is the same. Again, there's no coefficient on that squared term. There's no GCF also, so we just go straight into our parentheses. Our third sign is negative, so we know it's going to be 1x plus and 1x minus, so equal to 0. And then we just think to ourselves, how can I multiply to get to 48? There's 1 times 48, there's 2 times 24, there's 3 times 16, 4 times 12, and 6 times 8. Those are the ways to get to 48. We're looking for the factors of 48 that subtract to negative 8. 4 and 12 subtract to 8. We need it to be negative 8, so that means we're going to have a positive 4 and a negative 12. That together makes negative 8. Now that it's completely factored, we take each factor and individually set them equal to 0. And these are very easy equations to solve. On the first one, we subtract 4 from both sides, and x equals negative 4. On the next one, we add 12 to both sides of the equation, and x equals 12. There are your two solutions, negative 4 and 12. Numbers 7 and 8 looks like we might have a coefficient on the squared term. That's okay. Also, our equation is not set equal to 0. Remember, our first step is to get our equation set equal to 0. So really, our first step is we're going to move this over here to the left side by adding 49 to both sides of the equation. So those on the right cancel, and my resulting quadratic is 4x squared minus 28x. That was already on the left side. I'm just rewriting that. And I've got that now plus 49 equal to 0. So now that my equation is set equal to 0, I'm looking for a GCF, and nothing divides all three of these, so there is no GCF, sadly. And that means we have a number in front of our squared term, and that means we got to do the magic number. So 4 times 49 is my magic number. 4 times 49. Wow. I believe that's 196. Yes, definitely 196. So I'm looking for the factors of 196 that add to 28. Luckily, I'm pretty good at math, so I know that 196 is a perfect square. It's 14 times 14. And that also happens to add to 28. So remember, with my magic number, I can't go straight into the parentheses. I have to break that negative 28x into a negative 14x and a negative 14x. I did not change negative 28x, I just broke it down into two separate pieces. The other things just get rewritten. I'd have the 4x squared still, I have the plus 49 still, and the equal to 0. So remember, we made this 4-term polynomial on purpose for a reason, to factor it by grouping. We've done this. This is just a review really today. We take each of those two terms and group them together and look individually. What's the GCF of those two terms? What divides both of those? 2 and x divides both of those. If you were to divide both of those by 2x, that would give you 4x squared divided by 2x is 2x. And then 14x divided by 2x is 7, not x, just 7. In my second group, I don't want my first term to be negative, so I definitely am going to factor out a negative. And then what divides 14x and 49? 7 divides both of those. That's the biggest. And if we were to divide both of those by negative 7, a negative divided by negative is a positive. 14 divided by 7 is 2, and the x kind of tags along. And then that one should have been green, but that's okay. 49, a positive divided by a negative is a negative. 49 divided by 7 is 7. So that equal to 0. So you look, and remember, these parentheses should match. If they don't, you've done something wrong. Go back and try it again. So the matching 2x minus 7 gets factored out. So those are gone. What would be left over? The 2x minus 7 on the outside of the parentheses. So you'll notice on this one, both of the factors are the same thing. So if we were to individually set these equal to 0, they're going to, of course, produce the same solution. So we really just need to solve one of them, since it's going to be the same. And we know that we would add 7 to both sides of the equation. And if 2x equals 7, we would divide both sides by 2. Those 2's cancel, giving me a solution of 7 over 2. If it doesn't go into it evenly, just leave it as that improper fraction. And again, I don't need to solve this one because it's the same as that one, so I'm just going to have one solution. That happens sometimes. Most of the time you'll get 2 solutions. Sometimes they match, so you just get the same one solution. Number 8 is pretty similar to number 7. Again, the equation must be set equal to 0. So we're going to add 16 to both sides of the equation for our first step, giving us 9x squared minus 24x plus 16 equals 0. I'm looking for a GCF, and nothing divides all 3 of those terms, so we have to make that magic number by multiplying the first number and the third number. 9 times 16 is 144. Again, I know that if I get a perfect square over here, it is usually going to use that squared. That's just kind of the way the problems get set up sometimes. 12 times 12 is 144. 12 plus 12 also adds to 24, which is what I need it to do. So I just kind of recognize when I see perfect squares that it's probably going to work out. So I'm not going to go straight into the parentheses. Remember, we have to break down negative 24x into those two factors, negative 12x and negative 12x. If we were to put those together, you would still have negative 24x. We didn't change anything. Everything else just tags along for the ride. The 9x squared, the plus 16, and the equal to 0. So we did this on purpose. We did this to group the first two and to group the second two. In the first group, both of these are divisible by 3, and there is an x in common, so we're going to divide by 3x. 9x squared divided by 3x is 3x. 12x divided by 3x is 4. In the second parentheses, we don't want our first term to be negative, so we're going to divide by a negative. And the biggest thing that divides both of those terms is 4. If we were to divide by negative 4, we would get 3x minus 4, which again, those parentheses match. So we did it correct. If we were to factor that 3x minus 4 out in common, we would write the leftovers, which are those two things, which also is 3x minus 4. So it's a lot like number 7. Both of those factors match. So we really only need to set one of them equal to 0. And that's a nice, easy two-step equation to solve. We solve it by adding 4. 3x equals 4. Divide by 3 to both sides of the equation. And again, 3 doesn't go into 4. So we just write that solution, x equals 4/3. Nice and easy. Okay, just a few more examples here. We see different iterations of the same thing, but we're following the same steps. So on number 9, you'll notice a couple of things. 1, our equation is not set equal to 0. And 2, this isn't really helpful whenever there's parentheses touching each other like this, or I guess really just a factor times a parenthesis. So what we're going to do on the left is we're going to go ahead and distribute that x through. So that would be 2x squared minus 7x. And then we need our equation also set equal to 0. So we're also going to go ahead and subtract 4 from both sides of the equation, giving us 2x squared minus 7x, and then the minus 4 that comes over to the left. So we look at that resulting trinomial, and we're going to factor it. There's no GCF for those 3 terms, so we're just going to go ahead and straight into our magic number since we have a coefficient on that squared term. 2 times 4 is 8. Our magic number is 8. We're looking for the factors of 8 that subtract to negative 7. You should be able to recognize very quickly that that is 1 times 8. So we're not just going straight into those parentheses. Remember, we break down that middle term into those two factors. How can I make negative 7x out of those two terms? Well, that would be a positive 1x minus 8x, right? Remember, we are subtracting, so they have to have different signs. Everything else is going to be rewritten. So I've got the 2x squared out front, the minus 4, and the equals 0. And we did that on purpose for a reason, to factor by grouping. In the first group, there is an x in common. If we were to divide by x, that would leave you with 2x plus 1. If you look at the second group, you don't want your first term to be negative, so you're definitely going to factor out a negative. And then the biggest thing that divides both of those terms is 4. If you were to divide those by negative 4, you would have a positive 2x plus 1. And again, those parentheses match. So you're able to factor out that 2x plus 1 that's in common. And then you also have the leftovers. X minus 4 is the second parenthesis. So now that we've got it completely factored, we take each factor and individually set them equal to 0. 2x plus 1 equals 0, the first factor, and x minus 4 equals 0, the second factor. So this one takes 2 steps. First, you would subtract 1 from both sides, and 2x equals negative 1. Divide by 2, and x equals negative 1/2. The second one, you just have to add 4 to both sides of the equation, and x equals 4. See, number 10, same as number 9. We're going to distribute that x through, giving us 3x squared plus 7x. Then we're going to subtract 6 from both sides of the equation, so minus 6 equals 0. Again, there's no GCF, so we make that magic number by multiplying. 3 times 6 is 18. We're looking at the factors of 18 that subtract to 7. Hopefully you're thinking of 2 times 9. 2 times 9 subtracts to 7. 2 and 9 subtract to 7. It needs to be a positive 7, so that would be a negative 2x and a positive 9x. The other things get rewritten. 3x squared minus 6 equals 0. We did that to group them together. Group the first two, group the second two. X divides both of those first two, giving you 3x minus 2 left over. In the second group, 3 divides both of those numbers. So we're going to put plus 3. If we were to divide those by 3, we'd have 3x minus 2. That's good because those parentheses match. If they don't match, you've done something wrong. Go back and try it again. So these that are in common is my first parenthesis, 3x minus 2. And then the leftovers make my second parenthesis, x plus 3. Now that it's completely factored, we're able to set each factor individually equal to 0. So 3x minus 2 equals 0, and x plus 3 equals 0. So we've got a two-step equation there for the first one. We would add 2 to both sides, and 3x equals 2. Divide by 3, and x equals 2/3. On the second equation, subtract 3. That's a nice and easy one. X equals -3. All right. Then the last type of problem, 11 and 12. They're already set equal to 0. That's great. Remember, your first step is to look for a GCF. All of these are divisible by 2. And I don't want my first term to be negative. So we're also going to divide by the negative. So -2 is the GCF. What would be left over? X squared, now plus 2x and minus 15. Which is great, because if there's no coefficient on that squared term, we can go straight into the parentheses. So the -2 is going to tag along. My third sign is negative, so I'm going to have one positive and one negative in my parentheses. The factors of 15 are 1 times 15 and 3 times 5. I'm looking for the ones that subtract to +2. Obviously, that's 3 and 5. The 5 has to be positive. The 3 has to be negative. Now, really here, I have 3 factors. So I need to set all 3 of them equal to 0. -2 equals 0. X plus 5 equals 0. And x minus 3 equals 0. And as you write that first one, you think to yourself, -2 definitely does not equal 0. Those are 2 different numbers. This one we reject, we ignore it, and we just solve those 2 other easy ones. Obviously, this one, x equals -5, and on this one, x equals 3. So there again are your 2 solutions. And then number 12, the last one we have to do together, follows the same format. Again, first look for a GCF. Is there a GCF? Yes. 3 divides all 3 of those, and you don't want your first term to be negative, so you're going to divide each of them by -3. If you were to divide by -3, that would give you a positive x squared, a positive 2x, and a -24. Set equal to 0. Okay, so again, I don't have that coefficient on the squared term, so I'm able to go straight into my parentheses. My third sign is negative, so I'm going to have 1 plus and 1 minus. And then I'm looking at the factors of 24. They are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Remember, our signs tell us what we're doing. We're subtracting to make a +2. Yeah, 4 and 6 subtract to make 2. It would be a +6 and a -4. Again, take each factor and individually set them equal to 0. If -3 equals 0, that's not true. We reject that one. X would equal -6 there, and x would equal +4 there. And there are your solutions. So really today is just kind of a review of the ways that we factored before, and then just take each factor and individually set them equal to 0. So hopefully you won't have too big of a problem with this. Good luck, and use the rest of your time wisely.